Ever since the Earth was thought to be the center of the universe to this day, humans will deploy the James Webb Telescope at the equilibrium point between Earth and the Sun to better understand the universe. Man has gone through a tumultuous path of belief in science to know and explain the universe. But cosmology in its scientific sense started when Galileo looked at the sky by his telescope, and man's beliefs about the planets and the sun were shaken. At the beginning of the 20th century, mathematical equations were first used to explain the universe. In the 1920s, it was thought that the compatibility of cosmic equations and observations could provide scientific answers to cosmological questions. It gradually became clear that if this consistency exists at the macro level, there are still problems in the details whose answers are more doctrinal than scientific. Today, scientists hope that deeper observations by the James Webb Space Telescope could actually help solve some cosmological problems. But until we find a scientific and accurate explanation for these problems and the foundation of physics, it seems impossible to solve them. So the first truly scientific theory was Copernicus's model of the solar system. It was published in 1543. In 1609, two important events in physics arose that man's altitude and perception changed of the sky. Kepler published his first and second laws and showed that the orbits of the planets around the sun are elliptical, and the closer the planet gets to the sun, it moves faster. Physicists have dealt with two newfound phenomena. One was particle on a microscopic scale, and another was high speed close to the speed of light, which could not be explained by classical physics. Quantum mechanics was established to explain the microscopic world and special relativity for high speeds. Physicists had no problem with special relativity, and the problem of modern physics was to combine quantum mechanics with relativity. Combining quantum mechanics with special relativity was not really simple though, and its history is full of despair and hope and unfinished success. It is the result of continuous work of many physicists that the last century, each generation followed the work of the previous generation and is still not without ambiguity. But the combination of quantum mechanics with general relativity has been inconsistent from the beginning, and there is still no sign of promising success. It became clear over time quantum mechanics are more complex than which was thought. So that Feynman said, "I think I can safely say that nobody really understands quantum mechanics." On December 25, 2021, the James Webb with a 6.5 meter diameter mirror was launched to space and is supposed to be at a distance of 1.5 kilometers from the Earth, settle at the equilibrium point of the Earth and the Sun. In practical terms, the main difference between the Hubble and James Webb Space Telescope is basically that the Hubble works on the visible spectrum while James Webb works on the infrared spectrum. But Hubble was able to image the universe up to 500 million years after the Big Bang. James Webb will reduce that to less than 200 million years. The Webb telescope will study the history of the universe, from the first glows after the Big Bang, the formation of the first stars, the first galaxies, planets, and the origin of life, and systems such as the sun that are able to support life on planets like Earth. Just as the Hubble Space Telescope and other telescopes could not detect the moment of the Big Bang, neither can James Webb. Contrary to popular belief, that is the mystery of singularity, and the cause of the Big Bang will remain unsolved. Solving such mysteries is basically not the job of telescopes, because the telescope cannot theorize. Theorizing is the responsibility of humans, but the information needed for theorizing comes from experiments, and the telescopes where they're conducting those experiments on are the human eye in the cosmos. After observation, it is the turn of thought, analysis of information, and conclusion. This is why this is the James Webb era. And if you want to know more about how James Webb is in comparison to Hubble Space Telescope in detail, then check out this video right here. Otherwise, I'll see you on the next one. Cheers.